Now we'll come to what delta G will tell us about the reaction. Suppose a reaction is going on, very simple reaction, substrate is converted to product. It is a unimolecular reaction and the standard free energy change is delta G prime 0. So what it will inform us? So it will inform us about the spontaneity or feasibility of the reaction, whether the reaction is going to happen or not. So if we will draw an energy diagram of substrate being converted to product. So this is the substrate in ground state and product in ground state. So the free energy change under standard biochemical condition is given by this value. So this value informs us that the reaction will be spontaneous as the free energy change is negative. So the energy is released. So the product is more stable than the substrate. And what else? It will tell us about the equilibrium concentration of substrate and product when both are in equilibrium. So these two things will be given by this standard free energy change. However, it will not inform us about these things, the speed of the reaction or velocity and the pathway taken by the substrate to be converted to product, which is otherwise called as the mechanism of reaction, and the intermediates, those are formed during the reaction. So these things will not be informed by the standard free energy change. So here we need to understand that how a chemical reaction will happen. When substrate is converted to product, it has to go through an energy barrier. So we have already seen it in the introduction class that this energy barrier has to be crossed, and this state, which is the highest energy species created during the reaction, is called the transition state. So we'll be looking at the transition state in more detail. So this is the species, the highest energy species that determines the speed of the reaction. So in presence of enzyme, this energy hill is decreased, so this is the free energy of activation in presence of enzyme. So this energy hill is otherwise called as activation energy. So this amount of energy is the activation energy required for the substrate to be converted to product, whereas if the reaction is reversible, the activation energy will be this much. So as here product is more stable in compared to the substrate, the activation energy will be more when product is converted back to the substrate. Hence, we'll see how these enzymes control the rate of reaction by decreasing the activation energy. So here it is to be noted that energy doesn't change the free energy of the reaction, and hence it doesn't change the equilibrium concentration between the product and the substrate. So enzyme doesn't change this and enzyme doesn't change this. Only it speeds up the reaction. So it is like a barrier or a hill is decreased, so that more of the molecules jump this hill to come to the product side. So in the next videos, we'll see how enzymes decrease this free energy.